In section 2 of chapter 6, we're going to be dealing with rational expressions and functions again, but now we're going to be adding and subtracting. Now, some of the basic rules as a little background will be if we are going to add 1/2 and the fraction 1/3 together, in order to do so, we have to have a common denominator. That is, when you're adding or subtracting fractions, you have to have a common denominator. So we're going to be doing that with these rather complex things down below, but this is the process. What is the common denominator between these? Well, for something as simple as this, just multiply the two together and you get 6. Now, the thing is, what do we do to this denominator of 2 to make it a 6? Well, we multiply it by 3. But in order to keep this equivalent, we must not multiply the numerator by 3. Now, what is 3 over 3? That's actually a 1. So in a sense, we're multiplying this 1/2 by 1 in the form of 3 over 3 to make it have an equivalent denominator to 6. So this denominator then becomes 6. Our numerator becomes 3. So 3/6 is 1/2. And now what do we have to multiply 3 by to make it 6? Well, 2. And again, 2 over 2 is 1. So 3 times 2 is 6. 2 times 1 is 2. And now we have a common denominator. We just add our numerators and we get 5/6 for the answer there. So this is basically what we'll be doing, but with more complicated things. So let's move on. Now in example 1, they want us to add and simplify. The word simplify is critical here because, again, you may have the right answer, but if you don't simplify it, reduce it, and cancel out where you can, they will count it wrong. So we have the same denominator here. So a protocol might be, well, put your common denominator, and then just put all your numerators together. Now, actually, you could probably do this step mentally. So then this will equal 5 minus 1 is going to be 4. And we have x plus 4 all over x. You probably could have done that mentally, seeing you had the same denominator. Now, right away, they're getting into something a little more challenging. Here our denominator is the same. But we have to group our numerators and combine like terms. Since this is a plus, you don't have to change any signs. So this is going to be 5x squared. I'm doing this mentally. This one and this one will give us a plus x. And this will give us a negative 6. Now, as you look at this, and you might say, okay, that's our answer, but I see that this denominator is going to be able to be factored. So let's see what happens here. So I factored the bottom and I factored the top. And what do you see here now? Well, the x minus 1's are a common factor, so they will cancel out. So your final answer will be 5x plus 6 over x minus 6. Now, one of the things I meant to comment on over here is that you have an x in the numerator here and an x in the denominator. Can you cancel these out? And the answer is no. And you might say, why not? Well, because this is a term and this is a term. They're not common factors. You only can cancel out common factors, things that would make 1. That doesn't occur here. With terms, you can only cancel out common factors. Okay, let's go on and take a look at letter C. So as we look at C, again, we have the common denominator of m plus 3. Now this is a negative, so we're going to put this as a positive here and put our negative up there. That's a little technique that's often useful in doing this type of thing. So we have our 2m squared. Now a positive 7m and a negative 4m gives me a positive 3m, and you get a minus 9. Now I'm going to take a look to see if I can factor this, and we'll see if we can cancel something out. And it does factor into this. I checked it by FOIL, and now what can you do? Well, this will cancel with this. Now remember, this is a factor. That's why we can cancel it. All right, continuing. Now, in number 2, they want us to find the least common multiple of each pair of polynomials. So here we're trying to find the common denominators. So for this one, let me write it up here. X to the third, and we have 8x. And in a sense, we want to find a common denominator. Well, it's a common multiple. In terms of the number, remember there's a 1 there. We're going to need an 8. And then in terms of the x terms, the variable, it's the largest number of exponents that will be the common multiple. So it's going to be x to the third. That's for this one. Now for letter B, and I'll write it out down here, you need to factor it to see what are your factors. And this one looks pretty easy. X, 1, 1, plus, plus. All right. And this one, as you look at it, is a difference of perfect squares that are going to factor into its conjugates. X plus 1, x minus 1. Now, when we go to pick the common denominator or common multiple of these, the rule is, what's the greatest number of times that the x plus 1 factor is used in any one factorization? Well, this is a factorization. This is a factorization. What's the greatest number of times x plus 1 is used in any one factorization? And you might say it's used once, twice, and here it's used once. So the greatest number of times it's used in any one factorization is twice. So as part of our lowest common denominator here, we're going to need two of those. Now there's only one other factor used, and the greatest number of times it's used in any one factorization is once. So we need one of those. And that's the rule. So that's for number 2. Now for these next few, we're going to be adding, adding, subtracting, subtracting, and adding. And we need common denominators. So this will be our next little effort here, and we'll start off easy. And we're looking for a strategy here. And I have room there, so I'll put it right there. So what's my common denominator here? And we said it was x, or 8x to the third. Now, what do I need to multiply this item by, which will be a 1, but what will that 1 be? What form will that 1 take? Now I have x to the third. I need the 8. So my 1 over here will be in the form of 8 over 8. And what will this one need? Well, this one's going to need a 1 in the form of what? X squared over x squared. These are 1s. We're multiplying these fractions by 1, but in a special form that allows our denominators to become the same. So we go 8 times 7 is 56, and we go 4 times x squared is plus 4x squared. Now, you could leave it like this. I'm going to check to see how they go, because in a sense you could factor out a 2 from each of these, maybe a 4, and do some canceling. So let me check on that. So you can take a 4 out of each of these in the numerator, and 8 is 4 times 2. So now you have common factors. These can cancel out, and that might be the answer they're looking for. And let's check on that. And I see down here, yes, they did want you to factor out that common 4. Okay. I hope I had a 3 there anyway, because you can't cancel out any of the x's. Now in looking at letter D, this is what we had done up there. This was our denominator for this, our denominator for that. We said we had to factor this, and we factored the difference of perfect squares. By the way, this is a perfect square trinomial. It would be this squared, which we use 2, and we have this. So we figured out that this was used twice in any common factorization, so we needed two of those. Here it's only used once, so we used it twice. This one's used once, so we needed that. So this is our common denominator. Now, what do we need to modify? We're going to modify this fraction by multiplying it by 1 in the form of something that will make it this denominator. Well, it has these already, so we have to multiply this fraction by 1 in the form of x minus 1 over x minus 1. So that's just a 1 there, but it will allow us to have a common denominator. And this one is missing what? Well, it has one of these, but it needs two of them. So we need to multiply this one by 1 in the form of x plus 1. X plus 1. Now I have this, which I can just distribute, 2x squared minus 2x, just distributing that. But here I have to FOIL, and I'll do that. So I will multiply my first and get 5x cubed, do my outers and get a positive 5x squared, do my inners and I get a negative 3x, and then do my last and I get a negative 3. Now what I have to do is group like terms. So this is by itself, put it there. My 2x squared and 5x squared give me a 7x squared. My negative 2x and a negative 3x gives me a negative 5x, and then I just have a negative 3. And that will be the answer for letter D. And as you see, it does take a lot of time. There's a lot of algebra skills going on there. And, you know, you're going to have a chance to practice it. And on a test, you would only have one problem like this. Here they're giving us a variety of problems to do. All right, let's go on. Now, all I've done is taken letter E, written my numerators, and factored each of the denominators that I have right here. Now, this is a subtraction, so there's a negative sign right here. My strong suggestion is you're going to make this a positive and then put the negative sign up there. That makes things, I think, a little easier than worrying about this negative sign down there. Put it up there. Now, let's determine what our common denominator will be. What's the greatest number of times that x minus 1 is used as a factor in any one factorization? Well, it's used once, so we need one of them, y minus 1. Now, y minus 4 is another factor. What's the greatest number of times that y minus 4 is used in any one factorization? Well, here it's used once, and here it's used once. So it's used once, so I need one of them. Y minus 4. Okay, I've used both of those, so I need both of those. Now, what other factor do I have anywhere? Well, I have y plus 1. What's the greatest number of times y plus 1 is used? Once. So I need one of those. So this is the way to determine what your common denominator will be. Now what we have to figure out is we're going to multiply these by 1 in the form of what to make this denominator this? Well, this one has these two. I need this one. So it's going to be y plus 1, y plus 1. So there's my 1 that I'm multiplying this one by, so I get this common denominator. Now, which one does this one need? Well, this one needs y minus 1. Y minus 1. This is my 1 that I'm multiplying this fraction by, so it ends up with this common denominator. So what do I need to do now? Well, I need to FOIL here. And keep in mind this is a binomial here, so I can just do that one. This is going to be y squared plus 2y plus 1. Just foiling that. Now here I'm going to put a negative sign because I'm going to FOIL this, and I'm going to later change all the signs. So foiling this, I get a positive 2y squared. Then I get a negative 2y and a negative 5y gives me a negative 7y. And then a negative 5 times a negative 1 gives me a positive 5. Again, lots of algebra going on. Now there's a negative sign in front of this parenthesis, going all the way back to that. So what I'm going to do is take away the parenthesis and change all my signs. So I'm going to change my signs first. This becomes negative, this will become positive, and this will become negative. And now I can take away my parentheses here. This is just a little tedious here. Okay, now I can combine like terms. Now these are quite tedious. You can see all of the algebra needed to do just one example. So you know you're going to have to spend time doing this and doing it carefully and watching all your signs. And I don't believe this factors. No, it doesn't. So this is what the answer should be. I will check it though. And I should have a copy of the answers. I don't have one yet, but I'm eventually going to do that. Yes, I checked it and it is correct. Okay, let's go on to letter F, because that's sort of a different one. And we may try some of these others too. Now, notice what we have here. We have 4, 7t plus 1 over a negative 7t. And you might say, boy, these are very, very close together, except this one's negative. Well, do you remember we said we could put that negative sign, instead of being in the denominator, we could put that negative sign up there and make this positive. Whoa, isn't that great? And that's what it is. So 4 minus 1 is 3 over 7t. Ah, an easy one. But again, that little technique is really critical. So if you see something like that, just do that. Now, let's take a look at this letter G here, because I can see something similar going on. Now, before I write this one, do you see this one right here? It looks like that, except the signs are reversed. So what I can do is, remember, I could, well, we'll leave that there for now. Again, there's a couple of ways to do it, but I'm going to take a negative 1 out of this two terms here, and I'm also going to use the commutative principle to switch the order around, and I now get 5x minus 2y. So I've just taken a negative 1 out of that, reversed the signs. Where this was positive, it's now going to become negative. This is negative, it's now going to become positive, and I switch them around. Now notice, I have a negative here and a negative there. And we said we theoretically could have put that negative up there. And what do we have when we have a negative divided by a negative? Well, we have a positive. And just through a little manipulation, we're able to get a common denominator here. So our answer then will be 5x minus 2y in our denominator. And we're going to have here a 3x plus 4y plus 5. And it wasn't as tedious as this one. This was sort of easy, and this is just a little play on it right here. Okay, let's go on to our last one, and I'll write that out for you. Now, all I did was to rewrite this, but factor this, because what will my common denominator be? It's actually going to be this. So, what is this missing? I want to multiply this fraction by 1 in the form of something over something that's missing. So this one is going to be x minus 3 over x minus 3. And this one's going to be x plus 3 over x plus 3. So my common denominator is x plus 3, x minus 3 are conjugates of this first denominator. Okay, so again, I'm going to make this a plus and put my negative there. And that just helps with the signs a little bit. So this is going to become a 4. This is going to become a negative x squared. This is going to become a positive 3x. And this becomes a positive 2x plus 6. So now I'm just going to group my like terms. I get a negative x squared plus 5x plus 10 all over x plus 3, x minus 3. I don't see that this factors, so I don't have to worry about factoring anything. Okay, again, this is quite tedious just at 30 seconds, 30 minutes.